Three-phase transformer. In this video, I'm going to talk about three-phase transformer. All the power stations, they generate power by using a three-phase generator. Most of the time, that generator is going to be star connected because it needs a neutral. Neutral needs to be grounded for excessive current. If in the case of unbalanced load, the current is going to go through the ground. Now, for the safety purpose, they always use the Y connection. Now this Y connection is going to give it to a transformer. This is a transformer to transmit the power supply. Most of the time this power supply is going to be either 13.3 kV or 12.5 kV, something like that, 60 Hz or 50 Hz. Now this transformer, here we have a delta connection. Here this is going to be, the primary is going to be Y connection and secondary is going to be delta connection. The reason behind it is, say even if the transformer is 1:1, so N1 is 1, N2 is also 1. In that case, still the voltage is going to be on this side square root 3 times whatever on the V primary. Okay, that is one advantage. Another advantage is in transmission lines, here since it's a delta, there are only 3 wires. So when they build a transmission line, they need to build a transmission line for only 3 wires, not 4 wires. That's another advantage. Okay, this transmission line is going to be end up at a substation. Here you will have delta to Y, and then this Y is going to be distributed to the local loads. That's how a simple power system look like. Okay, so we have to have a transformer, three-phase transformer. Now those three-phase transformers, you can build it by using 3 single-phase transformers. So if you look at Y delta, here is my primary of 1 transformer, second transformer, and third transformer. 1, 2, 3. Now we can take these 3 transformers and make a 3-phase transformer. That's one way to do it. Another way is they can have 3 windings, basically 6 windings. So here is our primary, here is the secondary, primary and secondary, primary and secondary of the 3 phases. This is phase A, phase B, phase C. This is another way of building a transformer. Now I'm not going to talk about how to build a 3-phase transformer, but here I'm going to talk about what are the I'm going to find out how to connect those 3 transformers. Okay, 3 individual transformer or 3-phase transformers. Okay, now you can see we have 3 windings on the primary side, so total 6 wires. So 6 wires on the primary side and 6 wires on the secondary side, A prime, B prime, C prime. Okay, we can connect either Y connection, Y delta connection, delta Y connection, and delta connection. As I mentioned, this Y delta, delta Y is going to be used most of the time in the transmission system, okay, to transmit the power. Y and delta have limited applications. I do not have good answer for where we use it at this point, but they have limited applications. Now when it comes to the primary, so here VLP is the primary line voltage, VLS is secondary line voltage, ILP is the primary line current, ILS is secondary line current. I didn't indicate the phase voltage and phase currents, but there are phase voltages and phase currents. For better understanding, I'm going to say a few important points. Why if it is a Y side, on the Y connection, we know that P equal to root 3 VL IL cos theta, where cos theta is power factor. Okay, theta is angle between voltage and current, or 3 times VPH IPH cos theta. Okay, we know that Y connection IL equal to IPH and VL equal to root 3 times VPH. You need to remember these three. We already learned this in the three-phase circuits. Okay, when it comes to delta side, P is same, root 3 VL IL cos theta. Here we're going to assume it's an ideal transformer. When it's an ideal transformer, there are no losses, so whatever power supply is same as the power delivered. 3 times VPH IPH cos theta. When it comes to delta, IL equal to square root 3 times IPH. Okay, VL equal to VPH. Okay, these things you need to remember. Now I'm going to go with a simple example here. Here is an example. In this example, he gave us the primary voltage. Remember, in three-phase system, it is always the given values are line to line values. So if I say a three-phase 60 hertz or 11 kV by 33 kV transformer, okay, whenever you see this 11 kV, this 11 kV is line to line value. Same thing here, 33 kV is line to line value. Unless I specify, we always, anywhere in the world, we always take that as a line voltage. Now in this example, he gave us the line to line voltage on the primary side is 625 volt. Okay, now you can see these two lines indicates it's an ideal transformer, and the secondary is connected to a three-phase 40 megawatt 0.85 lagging power factor with 12.5 kV load. The question he's asking about, find the turns ratio. So what is N1 is to N2, the current on the primary side of the transformer and current on the secondary side of the transformer. We can find phase currents and line currents, everything. Now first thing, whenever I see that 40 megawatt and 0.85 and 12.5, I can find IL, right? The line current, ILS, line current of secondary or secondary line current, which is, P equal to square root 3 VL IL cos theta, either delta load or phase load. This is the same. What is the IL? So based on this, IL is equal to P over square root 3 cos theta times VLS secondary. Okay, so here is the formula. What is ILS? ILS equal to 40 mega, which is 10 to the power of 6 divided by square root 3 times 12.5 K. K is nothing but 10 to the power of positive 3 times 0.85. So here ILS equal to 2173.55 ampere. Okay, that is the line current of secondary. So the current passing through the line is 2173.55 ampere. Okay, now that's what he's asking for, so we're good on that. Now he's also asking for the turns ratio. The turns ratio N2 over N1. Actually, N2 over N1 is transformer ratio. We indicate with either N or K, and turns ratio is N1 over N2. We indicate with the A. This is turns ratio. This is transformer ratio. I always ask for transformer ratio, mostly not turns ratio. So here N equal to V2 over V1. Here we always use the phase values. That is really important. Okay. So whenever we are finding transformer ratio, we always use the phase values. It's the same as the currents, I1 pH over I2 pH. So this is the most important point. Now I already know the line voltage of secondary, line voltage of primary. Since it's a delta, we know that VL equal to VPH. So line voltage equal to the phase voltage in delta. Both sides we have delta, so we don't need to worry. So N2 over N1 must be N2 over N1 equal to V2 over V1. V2 I have 12.5K, so 12,500. 12.5K is nothing but 12,500 divided by V1 is 625. Actually, the V1, it's not 625 volt, it is 625 kV. My apologies, so I'm going to correct that, 625 kV. So 12.5K divided by 625K. KK get cancelled out. So N2 is to, or N1 is to N2 equal to 625 is to 12.5. This is nothing but 50 is to 1. So that's the turns ratio I gave you, but you can treat that as a transformer ratio too, depending upon how you take it, either N1 is to N2 or N2 is to N1. Oh, sorry, N1 over N2 or N2 over N1. Now I have the transformer ratio. Based on this, can I find the phase current? Okay, we always use the phase current. So here this must be secondary I2 phase. This must be I1 phase. Okay, so I1 phase over I2 phase equal to N2 over N1. Okay, what is N2? N2 is 1, N1 is 50. So now I want I1 phase equal to I2 phase times 1 over 50. Okay, now here I found the line current. Okay, this is the line current, 2173.55. Okay, that is I2 line current. Okay, so the relation between line current and phase current in delta, IL equal to square root 3 times IPH, or IPH equal to, in delta, I'm talking about in delta, IL equal to square root 3 IPH, or IL over square root 3 IPH equal to. So if I write it down, IL primary over square root 3 equal to IL secondary over square root 3 times 1 over 50. Square root 3 get cancel. So IL primary, ILP. Sometimes I'm using ILP for primary, sometimes I'm using 1 for primary. Do not confuse about that. Go with ILP for primary current. ILP equal to ILS, which is 2000. What is that value? 173.55. 2173.55 times 1 over 50. Okay, that will give you the primary current of phase current. I'm sorry, IL, that's the primary current of line current, because the square root 3 get cancelled out, so it's a line current. That value is 43.471 ampere. Okay, I'll stop this video here. In the next video, I'm going to solve a couple of examples similar to this. Thank you.